this we are coming to the first part, which is called net present value. Whenever we come to the term net present value, the word net will always show you that it is difference of something. So what that something means to us? So what that something means to us. So try to understand the concept of the amount that you're investing today. The amount that I am investing today is a way of cash outflow. So that is known as cash outflow from my end, and I am expecting some returns on the amount that I have invested. So that is showing me the cash inflow, and this cash inflow will occur for certain period of time. For example, I have invested in a machinery, say a machinery in a company, and this machinery is going to generate me benefit for 5 years, upcoming 5 years. Now if I have invested rupees, say 20,000 on this machine, then I will expect this 20,000 amount is my cash outflow, because 20,000 is going out of my pocket today. Now I will expect to get some return out of this machine in terms of operating profitability. Okay, that machine has to work for me to generate some positive cash flow. So those cash flow I'll be getting, say, within 5 years down the line. So suppose after investing 20,000 rupees, I'm getting, say, 10,000 in first year, 5,000 in second year, next 5,000 in third year, and finally till fifth year I'm getting some positive returns out of that amount that I have invested. So that is giving me the cash outflow. Now tell me that if I add up all these 5 years cash inflow and cash outflow, will that give me a proper decision of taking this project? See, coming to this equation that we have come across, this equation though seems to be very complicated, but it's a very easy if we try to understand. See, if you are looking for this, what is this? This is C1. But before that, look for this amount. This amount is C0. What does C0 means? This is the amount that I have invested from my pocket today. So this is my cash flow outgoing. That is why it is C0. It's today's amount that is going out of my pocket. So that is why it is given as cash outflow. Now, if this project works for 4-5 years, every year it is going to generate some cash inflow. So this is cash inflow first year, this is cash inflow for second year, and then it is third year value, and so on. Now any project will go for, say, around 4 years, 5 years, or 6 years, or maximum 10 years. So we are giving the formula in that term as C1 plus C2 plus C3 and dot 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 Cn, where n represents the number of years for which you will get some return out of that project. Now, what does this K represents here? As I have already mentioned that today if 20,000 is going out of my pocket and I am getting return, say here in first year I am getting 5,000. And next year I am getting, say, 6K. And upcoming year I am getting 7K. And so on. So after investing 20K here, after investing 20K here, I am getting some returns every year. First year 5,000, next year 6,000, coming year 7,000, and so on. Now say for 5 years, For 5 years, I am getting return of these values. 7K, and finally I am getting here in 4-5 years total as 2K. So looking at this, you can see that I have invested 20K, and if I add this 5K plus 6K plus 7K plus 2K, so it is coming to be 20. And suppose in the final year I'm getting another 1K. So it is coming to be 21,000. So by investing rupees 20K, so by investing rupees 20K, I am getting 21,000 as my return. So do you people think that this project is worth for me? Because I am getting the amount that I have invested, I am getting more than that. So there's the concept of time value of money comes. As I have already said, that amount that I have invested today is worth more than the amount that I'll be getting tomorrow. The reason is the time value of money. So for that reason we use a factor called discount factor. This factor is nothing but this is known as discounting factor. So we write this K as discounting factor, or it is the required rate of return. So for the first year, whatever will be my return, with that if my K is, say, discounting factor is here, say 10%. So I'll apply that 10% rate of return here for first year. For next year, for this year, you can see the power 2. The reason is it is for the second year, and so on for the third year and so on. So from this formula we have come across the final formula, which is Ct by 1 plus k to the power t minus C0, where C0 is the amount that has gone out from your pocket today, and these are the total cash inflow you're getting. So this is my net present value. So what does net present value finally comes to? It is nothing but it is the discounted value of the cash inflow minus the cash outflow. Now, how do we analyze that the amount that I have invested is worth for me or not? So for that there is a simple logic that if my net present value today is coming to be positive or greater than 0, then in that case we will think that investing in this project is worth for me. So that is what the next slide shows you. So see, this is an example where some investors has invested in a project called X. This is the project. This cost rupees 2,500. So this is the initial investment for me or the one who has invested, and is expected to generate year-end inflows of rupees 900, 800, 700, 600 and 500. So you can see these are the various cash inflows you're getting from this project for coming 5 years. Okay. So how do we represent this in that formula? See, this is my first year amount. So first year amount was 900. So it's coming from this part, 900. Rate of interest they have applied is 10%. So I'm using that 10% rate of interest in place of K. So this is your rate of interest. This is for first year, so you have used the power 1. Then the next year cash flow, then third year cash flow, and so on. After solving this, whatever amount you're getting is this amount, 2725. Now originally if you look for, you have invested rupees 2500, and after discounting you're getting the amount as 2725. So now you'll find the net present value. So net present value is nothing but it's the difference between the amount that I have invested and the amount I am getting. So that difference gives me rupees 225. Now This project, now this project has given me the amount 225, which is a positive return. So this is a positive return for me. Now this project giving me the positive return is going to increase the value of the project. So that's why investing in this project is a positive decision. That is, it is going to create some benefit for me. Now, as we have already discussed, why, on what basis you should say whether investing is a opportunity, is a good opportunity for you or a loss for you. So as I have said, since it's a positive return, you look for, since it's a positive return, it will increase the shareholders value. Other thing is the cash inflow is greater. So in a way your benefit is more. So you will think of accepting the project. So here is the 3 acceptance rule for this project. Now accept the project when this is a positive value. This is accept. Reject when this is a negative value. Like your cash outflow is more and your cash inflow is less. And finally, you will be indifferent. Like indifferent whether you take the project or you don't take the project. It's not going to give you any, either any loss or any benefit. So that's why if NPV comes to be 0, you should be indifferent to that project. These things have already been mentioned in NPV thing. Whatever we have taken into account is mentioned. Next is profitability should also be there. And other is value additivity. Value additivity is nothing, but it is like if you are investing in a project A and a project B, and some of these projects should be greater, or it's sum of like NPV from both the projects A plus B is equivalent to individual NPV. NPV of A plus NPV of B. So that is why we call it as a value additivity. Like we can include 2 projects investment, separate investments in 2 projects is equivalent to together. And finally is the shareholder value. Limitations is discount rate which we are applying as the 10% or 5% is very difficult to determine. That is why this is for NPV method, it's very like one of the most crucial thing is deciding on the discount rate, on the required rate of return that you will be thinking of getting.